Alright, so we've got lower bound, we've got a lower bound, and we've got an upper bound. We want to prove the lower bound is lower than the upper bound. Makes sense, but you still need to prove it. So here, alpha is a lower bound, which means that for all x in the set E, x is going to be less, alpha is a lower bound, so alpha is going to be less than or equal to any element of E. And what else? We also know that beta is an upper bound, which means that x must be less than or equal to beta. Okay? So, let's see here. Prove that alpha is less than or equal to beta. So, since E is non-empty, we know that there exists some element x in E. So, since alpha is a lower bound, alpha is less than or equal to x, and since beta is an upper bound, x is less than or equal to beta, and this implies that alpha is less than or equal to beta. And that's all there is to this proof. And there's two things I want to take note of here. First of all is that it's absolutely necessary that E be a non-empty subset, because we needed to be able to select this element x because we couldn't construct the inequality without it. Furthermore, here is a false proof of this claim. So for every single x in E, alpha is less than or equal to x. So in particular, setting x equal to beta yields alpha is less than or equal to beta. It's very tempting to give this proof, and it is a wrong proof, because we assume here that x is in E, and we don't know if beta is in E. Beta is an upper bound of E, but that doesn't mean that it's in E, and that's a really essential fact about upper bounds, is that upper bounds of sets do not need to belong to the set. Now, there are some sets which do contain their upper bounds and their lower bounds, but that is a very important property of those sorts of sets. And that's something that we will be talking about a lot in analysis as a whole. But yeah, so anyways, here's a false proof that you do not want to do. It might be tempting to do if you're just looking at this, if you're still getting used to how analysis works, but you're not using the you're not using this fact here, and so the conclusion, like the definition of lower bounds, it doesn't apply here, and you have to go with the first proof that I gave. But the first proof, it's pretty short, but that's all you need, and that's it.